Welcome to Veera's classroom. In the series of problem we have seen regarding the block diagram reduction, this is the third problem. When you are going to see the problem given here, you can find the block diagram is much complex than the previous two problems. So whenever we are going to solve the problem, we will see whether there is a series or parallel component that can be combined. This is the first step to be done. So first step, whether we have a series or parallel, we do not have series and parallel at all. The G2 and G3 might be seems like a parallel, but it is not parallel because we have a branch point between G2 and the summing point. So what we are supposed to do, we have to move the branch point or the summing point here and there such that we get the parallel or series. We have two methods here. You can do it in two ways. I have done it in one method. What can be done is, the branch point that is between the summing point and G2 can be moved to the right of G2, or else the branch point that is between G2 and the summing point can be moved to the left of G2. We have two branch points near G2. Both the branch points can be moved to the left or right so that we can solve. So what we are going to do, what I am going to do now is, I am going to move the branch point that is between the block G2 and the adjacent summing point to the left of G2. So I am moving it in this left of G2, that is the step number 1, moving the branch point to the left of block G2. So when you are going to move the branch point to the left of G2, we are supposed to give a compensation in the feedback element, that is G2. So we have given the compensation. After completing this step, we are supposed to check whether there is any parallel or series component. We have a parallel component G2 and G3, and we have a series component H1 G2. So we will combine all those things, combining the blocks in series H1 G2 and blocks in parallel G2 and G3. So the combined block is displayed here. R is the input and G1 is the transfer function. The parallel component G2 plus G3 has been combined, and the series component H1 and G2 has been combined. What is the next step? What is the next step? Here also we are in the deadlock because we do not have a feedback loop, a proper feedback loop, or a parallel or a series. Nothing is available. So what we are going to do here is, we are going to move the branch point that is between the summing point and the G2 plus G3 again to the right of G2 plus G3. In the previous step, the step number 2, step number 1, we have moved this branch point to the left. Now we are moving the same branch point to the right. So the step number 3, we are moving the branch point to the right of block G2 plus G3. So when it is moved, we are supposed to give a compensation in the feedback element, which is H1 G2. So we are dividing H1 G2 by the transfer function, which is G2 plus G3. So the element is H1 G2 by G2 plus G3. This is the new feedback element. Now this is a simplified diagram because we have 3 feedback loops. All the 3 feedback loops are simultaneous. There is no deadlock at all. So we will start with one by one. The first feedback loop has a transfer function G2 and G3, G2 plus G3, and a feedback element H2. This is a negative feedback. The negative feedback formula is C by R equal to G by 1 plus GH. So we will substitute the same thing, eliminating the feedback loop. So we are eliminating it, and we are finding the answer C by R equal to G2 plus G3 divided by 1 plus H2 into G2 plus G3. So instead of this feedback, which is represented in the dotted line, has been replaced by this block of G2 plus G3 divided by 1 plus H2 G2 plus G3, and this block of higher terms is in series with G1. So we will just multiply G1. So the adjacent diagram will be G1 into G2 plus G3 divided by 1 plus H2 into G2 plus G3. Now we have another feedback loop. Most importantly, this feedback loop doesn't have any feedback element. If you do not have any feedback element, the element to be assumed as 1. So this is again a negative feedback. Formula is going to be C by R equal to G by 1 plus GH. Since the value of H is 1, the formula is going to be G by 1 plus G. So this is going to be simple. So this is simple, and C by R equal to G1 into G2 plus G3 divided by 1 plus H2 into G2 plus G3 whole divided by 1 plus 1 into G1 into G2 plus G3 divided by 1 plus H2 into G2 plus G3. After taking that LCM, the final equation is going to be G1 into G2 plus G3 divided by 1 plus H2 into G2 plus G3 plus G1 into G2 plus G3. This is the final term. So, this final term is going to be substituted instead of that feedback loop. So, we have substituted. After substituting it, we have another feedback loop. This feedback loop has to be considered. So, this is again a negative feedback. This feedback element is much more bigger than the previous terms. So, we have to do it carefully here. The formula is simple, G by 1 plus Gh, but the G value and H value are somewhat larger. So, G value is going to be G1 into G2 plus G3 divided by 1 plus H2 plus G1 into G2 plus G3 whole divided by 1 plus the feedback element H1 G2 by G2 plus G3, the feedback element is mentioned here, into G1 into G2 plus G3 whole divided by 1 plus H2 plus G1 into G2 plus G3. We have certain cancellations. After that cancellation of G2 plus G3, we will take an LCM of that denominator, and after that LCM we will have a cancellation of the denominator, and the final C by R is equal to G1 into G2 plus G3 whole divided by 1 plus H2 plus G1 into G2 plus G3 plus H1 G1 G2. This is the final answer for this block diagram. If you like this video, subscribe to the video and share it with your friends, and click the bell icon for constant updates. Thank you.